In this video, we're going to go over the Lab 6 calculations using the area under the curve method, as well as create several graphs to illustrate and look at how O2 changed during 40% of VO2 max and 75% of VO2 max performing exercise at those intensities. Alright, so if you want to go ahead and make sure you can have some Lab 6 up here, the worksheet. You can have both I have the minute one here and also the breath by breath sheets up. Make sure you open both those up. We'll be using both of those in here. For this, I'm going to start with actually the minute by minute one. It may not have, yours probably won't have this stuff over here on the right. This was just some stuff I did for some illustrative purposes. It's nothing that we're going to be calculating here. It's just kind of interesting, and we'll highlight that as we go along. So first things first, we're going to use this to identify where steady state occurred during exercise. Alright, so 5 minutes of rest, then 10 minutes of exercise here, and then another 5 minutes of rest or so. And you can tell it kind of, the minutes leaked into the next minute, and so we have just a hair bit of wattage, so to speak, in there, but it's fine. We're good. And then another 10 minutes of exercise, and then 5 minutes of rest. So we expect to reach steady state somewhere around 4, maybe 5 minutes into exercise, so somewhere around 10, and actually started exercise here 1 minute in, 2, 3, 4, 5, and it's settled pretty well for me. This is my data, 5 minutes in, because you can tell by how closely these VO2 numbers are just pretty much not changing. You can tell 1.42, 1.40, 1.40, 1.42, 1.40. So it was changing at most maybe 15 or so milliliters per kg per minute. Sorry, not milliliters per kg per minute, just milliliters per minute. 15 milliliters per minute. So we're rock solid. And actually you can kind of see that over here as well. These are just differences from what it's supposed to be versus what it actually was. And if you remember back when Lab 2, we had 0.111 for liters per minute as 117 for that. And you can tell here, pretty rock solid. We're within a little bit above, but that's fine. That's what it is. But we're well within range. Cool. Alright, so I reached about 5 minutes in, so when I'm going to figure out what my exercise VO2 is later, I'm going to take the average of those last 5. And then if we take a look at the second work rate, which for me was 177, my first one's 68, I'm going to look over here. So first minute in, we increased to 1.22, 2.23, 2.28, 2.60, 2.79, 2.88, 2.89, 2.92, 2.97, and 3.02. So it's just kind of slowly increasing still. And that was all the way through 10 minutes of exercise. This is not unexpected, actually, because I don't know what my exact ventilatory threshold is, but I was piloting at, and this is actually based off of an old VO2 max 15 years ago that I did. I never reached steady state. So for this one, we'll only be using that last minute. You'll have to go based off of yours. You have to look at your data to figure this out. But I'm certainly not within. And it's just highlighted over here by, okay, here's the first minute. We expect not to be using oxygen in the first minute. It's slowly increasing, and about 4 minutes in, I'm pretty much within range of what's expected. But then you keep looking, oh, those numbers are going up. Oh, so, and right now I'm half a liter off of where I'm supposed to be at the end. So I'm in phase 3 of O2 kinetics. Easily able to tell that from this. You'll have to look at your data. You don't need this, as I said. It's just a nice illustrative purpose to it all. But you can tell it's just slowly increasing. I mean, just minute 30 off versus minute 28, I'm 100 milliliters per minute off. So pretty good amount. Not within steady state. Not at all. It's slowly increasing. All right. So let's go do our O2 Kinetics stuff on this sheet. So we're going to start by adding 2 columns, starting with column D. And then here, we're going to put 3 sort of headers, rest VO2, and then 40% VO2, and 75% VO2. Okay. And for this, we're going to do equals to average. This is just our resting value, which is the first 5 minutes. We're not going to use the whole 5 minutes. We'll use about the last 3. So we can start it. Looks like I hadn't started pedaling here, so I can start here, and we'll go 2, 3 minutes. So that's the last 2 minutes right here. Let's actually use minute 2 as well. Okay, so that's my rest. That's what I was at rest. And then let's do 40%. Now remember, you have to go based off of what your minute by minute stuff was on this sheet. Here, for the 5 minutes, I was in steady state. So I'm going to go from 15 to basically just before 10. So through 11 minutes. I'm going to have to scroll down. Let's see. So 15 up through, not including any of the 10s. Okay, 1102, 0.02. And that's a number I expect, 1.40 because I had those 1.42s, 1.40s in there. And for 75%, for me, it's just going to be the last minute. Just the last minute. Let's go to 30 for me. Again, based off of your data. So here, 29 for me. There's a lot more data points because there are more breaths. Breathing faster. All right, and that's a number we'd more or less expect. Some of the things may not line up perfectly, time-wise between these two, depending on how it averaged on the minute by minute and your average. So from here, we can go down and we're going to make some row cuts, I like to call them. I'm going to cut off the 5 minutes, because this is where I'm going to start exercise. And I'm going to go to the end of exercise, 15 minutes. So 15, add 2, and then go to 20. Okay. Here I'm not doing any exercise. Here I'm just starting exercise. And then we're going to go to 30. Just using my mouse wheel. I could do page down as well. And right here we end. Right here I stop pedaling, and the bike doesn't go to 0 immediately on the bike itself. Even though it's programmed in to go to 0, it's still coasting, so to speak. Okay, and we don't need to add anything at the end. All right, so we're going to come back up to 5 minutes. 5 minutes. All right, so what we need to do first, and actually let's go up real quick and we're going to add to these headers. I forgot to add those. So this is going to be the difference, and then this is going to be the area under the curve, VO2. Just liters per minute. We're going to get rid of minutes when we do some multiplication, so that's why this one is only liters. Okay, come on back down. Equals to, we're going to take this, at minute 5, 5.09 by mine at least, and we're going to subtract from that our current VO2 at 40%. So our VO2 at 40%, what we're supposed to get to, that's going to be our VO2 that for steady state. We're going to subtract all of our numbers from that. And before I do one thing, I'm going to add some dollar signs first for the column as well as the row. It's going to tell it to hold that, I'm going to highlight that, to hold this the entire time. And I can just double click. And we added those cuts because I'm going to do control down. It's just going to do that for all that, for the 15 minutes. That makes this nice and easy. So I don't have to do anything like go back and change things. Not too bad. Control up, or it might be command up for Mac users. Right here, I'm going to add a 0 to start us off. And now what we're going to do is the area under the curve. So equals to 2 parentheses. We're going to find the midpoint between these two differences, which is this one plus this one. Close one parenthesis, divide by 2, close another parenthesis. That's just finding the midpoint between those two. And then we multiply by the time difference between those two measurements. So always starting with the last, or the last one first, and then the one that occurred beforehand. So since we're multiplying by time here, that gets rid of the liters. That just makes it liters. Gets rid of the minutes from liters per minute. Okay. And oh, one thing I forgot to do, plus. And we're going to do plus the previous number. This is going to do what's called cumulative sum. It just makes it so you don't have to do sum at the end, which is kind of nice. Okay, so for this, over this entire period, I would have been in deficit about 0.8 liters overall. And then we'll do the same thing for our EPOC. So we just figured out the O2 deficit here. If you want to enter that number, you could. And then we're going to figure out the EPOC here. All right, equals to this one minus, we're going to go back to our resting value. May have gone over one row too many. That's okay. Oh, nope, I'm perfect on how I did it. So here, I'm supposed to be at this level of rest, but I'm breathing more than I need to. Again, I'm recovering from exercise. It makes sense. I'm just ending exercise, quite literally. Added those dollar signs back in. Can double click. Always check. Yep, that makes sense. Oh, this fits on one entire screen. I like that. We'll add another 0 here. And we're just going to, actually, you don't even need to do this. It's kind of nice. So I'm just going to copy this previous one, put it here. I can always check though. I can always check. This is going to add these, divide by 2, this minus this, multiplied by that, and then add in the previous number. Easy. And so here I got to 0.94. So okay, I actually repaid that deficit by the end of my 5 minutes of rest. Very good. And then we need to do the same thing for this, for 75%. So equals to this minus 75%. So it's going to be, I'm going to accumulate a lot of debt on this one, unfortunately. So we'll see how it goes. What's the damage done, so to speak? Oh, whoops. Let me undo that. I forgot to add my dollar signs in. Dollar signs. It's always a good check because that next number was a positive number. I'm like, it shouldn't be. It shouldn't be. All right, there we go. And then here, we're going to add that 0. Copy, paste. Can always double check. Okay, it's good. Go down. Shoo, boy. 4.84 liters. Boy, that is a lot of deficit compared to my 40% condition. So it makes sense. I never really reached steady state. And lastly, let's do our last EPOC. So I'd put in 4.843. I could 3 or I could put a 4 in there instead because if I wanted to round up. But our last rest. Okay. Add in those $signs. 0. Copy, paste. Easy. All right. And so after exercising those 5 minutes, I repaid 3.040 liters of that deficit. I still have some deficit to make up, but repaid some of it, so good. So that takes care of this one. Our exercise VO2s, if we want to come back up, would just be from here and here. Those are our exercise VO2, steady state VO2. There's no place to put the rest, that's fine. Just leave it on here. We need it though, we need it. And work rate, we already got from one of our previous tables, but here I can tell I'm clearly at 68. Oh no, I'm 6 digits in, I'm off by point whatever. Okay, it's as close as we can get, as close as we can reasonably control. And then here I'm at 177, so okay, makes sense. You can just put those work rates in there. All right, let's go ahead and take care of question number 8 on here. So first we're going to do command or control on mine. Click that one and we can just scroll on down through 0 to 15. Then same thing for VO2. 0 to 15 and area under the curve. Oops, there we go. Let's insert. It should have taken. Oh, whoops, I accidentally was clicked here. That's why. Here, it had no idea what to do with that. It's like, this is a point off in some weird space. What are you doing to me? What are you trying to pull? All right, so we go through that again. Here we go. So this was our 5 minutes of rest. Weird sort of outlier up there. But 5 minutes in, we see the start of exercise, pretty linear, and then takes on a weird characteristic here to steady state. Steady state we know occurred about 10 minutes in, from my data at least, from my data. And we see all sorts of numbers all around here. Those are real breaths. It's what was measured. It's not like there was some problem with it, but we see a pretty linear portion in here from 5 minutes in, and then it gets a little bit crazy from there. All right, now let's take care of our 15 to 30. Actually, let's, yeah, that's good, 15 to 30. So we're going to need to highlight, get clicked off that stuff. We're going to go time. We have to scroll down to just past 15, basically when we ended exercise. Here, and go through 30. Same thing. And one more. Let's see, we're in E. All right, another one. And let's make this better. Let's start it from 15. There we go. And go to 30. Cool. There are a lot more breaths in here. Okay, so we can see our linear portion in here within the first 50 seconds or so of exercise, and it takes on a different sort of curve. So phase 1, phase 2, and actually I never reached, I reached phase 3 in this one. So yeah, pretty interesting stuff. And actually with my data, I had to remove the spit trap right at about 23 minutes, and we can see what happened in there with it. I had to remove it to replace it because it was so full. So When you guys have your data collection, you should be using the masks instead of a regular mouthpiece. So hopefully we don't have these issues with you. But it's okay. My data's just fine. It didn't affect the actual result, but you can see it's slowly increasing, even though, you know, there's up and down, up and down, up and down. It's slowly increasing. All right, so that takes care of those. Oh, we selected the headers so that we would have appropriate here, be able to tell VO2, air under the curve VO2, and that sort of thing. That's the one reason why we did that. All right. And the area under the curve is very easy. It makes it very easy to tell which portions you're in, whether you're in phase 1, 2, or 3. Makes it a lot easier. So that's why I used them instead. Use it instead, sorry. Okay, get rid of that. All right, so let's see. Now we'll need to come to the 1 minute spreadsheet because we just did number 8. Number 9, you're going to answer based on yours. Number 10, I'm going to come to the 1 minute one, and we're going to make a scatter plot using all 35 minutes, VO2, VCO2, and time. This one's pretty easy. So here we go. Just the same thing again. We'll insert. All right. The 1 minute ones are much cleaner looking. But if we only use the 1 minute ones for this, we'd be off by a lot in terms of O2 deficit and EPOC. So we want to make sure that we use the minute by minute one. Not for that, we use the breath by breath one. All right, so just some interesting things that we can see, at least in my data for this are, oops, there we go. All right, VCO2, VO2 are tracking pretty well, and then VO2 is increasing. VCO2 is increasing as well, but it's staying more or less below. It popped up once above here, that sort of thing, and then post-exercise, VO2 is falling faster than VCO2. They're not increasing, but VCO2 is decreasing slower. So what you see with that is you can come to your RER column here. So post-exercise, about 15 minutes. Let's actually full screen this. Zoom in slightly. Yeah, there we go. This will make it a little bit easier to see. So about post 15 minutes, we see RER going up, even though both VO2 and VCO2 are going down. That's expected. VCO2 should decrease slower during the recovery process than VO2. All right, and then 20 minutes, we start our next phase of exercise. VO2, it's going up. Again, that 23 minutes here, I had a drop in my VO2 just because I had to remove the spit trap to get that out, but it was quickly replaced. And then we continued on. I was still pedaling and all that. Actually, I did it myself while pedaling, so that was fun. What's interesting though is VCO2 just goes through the roof compared to VO2 here. And I think I can see why. If you look at my respiration rate here, respiration rate in breaths per minute, 24, it's at 27. We can see what the RER is there. And then it was a little bit slower for a few here. And what's happening to it? It's going up. And that's one thing about RER. It is very breath rate dependent. In some ways, it's very breath rate dependent. If you're breathing too slow, you'll just accumulate more VCO2. There's more time for exchange to happen. It's like if you held your breath in a Valsalva or just held your breath for a long time, you'd have a lot of VCO2 building up in there. So your next breath out will be, or breaths out will contain a lot of VCO2 and so on. But as soon as I was, increasing my breath rate to what it should be for that, it started decreasing. So that's more of an anomaly than something that's expected to happen. But yeah, it's just how I breathe during that exercise. So, and then post-exercise, we see the difference is even more stark post-exercise compared to our 40%, where VO2 crashes faster than VCO2, and we can see that complementary in, this is quite literally 32 right here. It's just the VCO2, VO2. So, some interesting stuff here. All right. Let's take a look back. That should be everything.